So good evening students, welcome to the second class of the Lovechem having the topic gaseous state. Gaseous state, or simply we can say states of matter, right? In some books it is mentioned as gaseous state, in other books it is mentioned as states of matter. So we are dealing with the lecture number 2, right? Lecture 2 we are going to discuss here. So today our main concept, before beginning the topic, the objective of today's topic, we can say objective of this class is actually the information regarding the equation of line, right? Equation of line we are going to learn, right? So what is the role of equation line? Many of the graphs we are going to discuss, many graphs we are going to understand in that case. Like Boyle's law have a different graph, Charles' law has a different graph, Avogadro law has a different graph. But information about the graph for different factor, for with respect to p equal to 1 upon v, p equal to v, these information, how to plot the graph, that is most frequently asked in the our respective competitive exam also. Many time it will be asked. So those who are actually from maths background, they already have a hint about this. Those who are actually from not from maths background, no need to worry about it. Simply we will actually undergo the concept easily. So our topic is actually equation of lines. So equation of line will give you the information. What is actually the independent axis? What is the dependent axis? What is the slope? What is intercept? Those information we are going to guess. So first thing first, we are going to deal with the independent variable as well as dependent variable, slope. So first graph we are going to discuss, the first one is the graph 1. So equation of line, first equation of line we can say it is y equal to mx. This is the simplest graph, right? So this is actually the equation of line having no intercept, in that case we can say, right? And slope from origin. Slope from origin, in this case we are going to draw. Y equal to mx, the simplest version we are going to discuss about. So no need to worry, origin means the 0 point at which the x and y axis both are 0. So let us draw the graph in that way. No need to worry, just understand the concept carefully. So here we are going to do y equal to mx graph we have. Y equal to mx we have. So there is y axis, this is your x axis here. So here in this case there are variable, this is y is a variable, another is x variable. And one slope is there in between. Now information regarding the slope then also I will give now in this case. So this is the graph. This is your graph here. So here this thing, there is actually theta angle in between them. So this theta angle, we write m is equal to tan theta. That is the slope. Now here the terms are there. Now what is x, what is y? Some of you might be wondering. Since the junior classes you have studied about the x, y, m, but no problem. Some of you might have heard about y is equal to fx, or we can say y is a function of x. But what is the use of x? So x here stands for the independent variable. X stands for the independent variable here. So independent variable means which does not depend on the value of the dependent variable. Here in this case the x value can be 0, 1, 2, 3 and so on, even 0.5, 1.5 and so on. These value does not depend on the value of y. While in this case of y is actually the dependent variable, right? Y is a dependent variable. So dependent variable means if the value of x is changing, similarly the value of y will also be affected in that case. And m, we already know it is a slope. M is your slope here. So let us actually get the idea about its slope. Now other word about the slope. Slope is actually tan theta, we got an idea. Or the slope also we can randomly point out. Means we can randomly also calculate the slope. That's why slope is also known as the change in y-axis with respect to change in x-axis. Okay, change in y-axis with respect to change in x-axis, that is your respective, we can say, the slope. No need to worry, just understand the concept here. Now how the concept regarding the y-axis and x-axis I am going to show, just observe them carefully. Here we have. So what we understood, we have got the information about the slope also. So let us continue for this. Let me actually raise a bit so that it will be clear. So change in y-axis with respect to change in x-axis, that is called as a slope. So how I can explain the slope? Watch this carefully. Here we have, remember the graph, y-axis is here. There is another graph here, in the same one there is x-axis. Let me show with the 2 points so that you can easily understand the change. This is your y-axis and this is your x-axis. So suppose this point as y1 and this point as y2, and we have a slope in that case. We have a slope in this manner with the blue pen I can show. Here we have a slope, correct? Now how to calculate the change? If we have to calculate the change in slope, so just do one thing, extrapolate the lines in this manner, right? And this is another line for y2. So we have to calculate the slope at that instant point. Now do one thing, we have the y1 value. This point is actually y1 and it has independent variable x1. At this point it is meeting at y2 and it is depending and it will meet at the x2 value. So this line I am going to show with the red pen color. So this part, from here you can just calculate a theta angle from this. So here we can calculate the slope in this manner. You know, m is equal to tan theta, right? Or here the change in y-axis with respect to x-axis. So this is actually the change in the y-axis and this is actually change in the x-axis. So we can write y2 minus y1 divided by x2 minus x1. We can say the slope in that way. So difference in y-axis with respect to x-axis, this you can write it as delta y upon delta x. So slope is also given in this manner also. That is change in y-axis with respect to change in x-axis. It will also give the information regarding the slope. Okay. So this is the simplest graph, y equal to mx, where x is the independent variable, y is a dependent variable, m is a slope. And the line is passing from the 0 point. This 0 we say as a origin. Okay, this is your origin here. Origin means x-axis as well as the y-axis both are 0 at this point. X as well as the y-axis both are 0 at this point. So this is a y equal to mx. Going for the next one now. Going for the next one here. So we are going to deal with the second graph here. The second graph is actually y equal to mx plus c, right? So second equation of line y equal to mx plus c. So this is actually equation of line having positive slope. Okay, positive slope, or we can say the ascending slope, right? Means increment is happening, ascending slope we can say, with a positive intercept, right? Positive intercept or simply ascending intercept, right? So this is the idea. We are going to deal with the y equal to mx plus c graph. So here let us begin. So in this case, what is actually C? So here we have y, already we got an idea, it is a dependent variable. Here we have a dependent variable, correct? Then we have m, that is a slope, we already know about it, like in the previous line. So m stands for the slope of line. In that case, x stands for the independent variable, and c stands for the intercept. C stands for the intercept here. So these are the equation in a given y equal to mx line. So let us begin with the graph in that way. We are going to deal with the graph of this one, y equal to mx plus c. Right. So y equal to mx plus c we are going to discuss about. So in this we have two axes. One is y axis, that is a here dependent variable, and then we have a x axis, that is a independent variable. So two axes we have drawn. Right, two axes we have actually drawn here. So here we have y axis, here we have the x axis. In between this one there is actually a slope, but before that there is an intercept. So see here, intercept is along the y axis. So this part from here to here, this distance to this distance, this C stands for the intercept, and remaining part here I can show with different color pen. Here this dotted line I can show. So this angle we can say theta. Theta is equal to the tan theta, that is slope. This is the slope. So here the line, the slope of line is ascending actually. The slope of line is actually increasing in this manner, right? So there is increment happening. The slope is ascending, and there is actually here in that manner it is a positive part, right? It is actually positive part here. This is the origin 0, 0 point, and the intercept is above 0. Intercept is above 0. So we can say it is a ascending one, positive intercept we can say. So this is a positive intercept. This is a idea about the y equal to mx plus c. So this is your x axis. Here we have the y axis accordingly, and in between this reddish line which I am showing, that is a slope, and we already know slope is actually change in y axis with respect to x axis. Here there is a positive intercept because it is above 0. So this is a one graph. Similarly, going for another graph. Next here we have, in this case, the third graph we are going to deal here, that is y equal to minus mx plus c. This is a third graph we are going to deal about. So this graph actually means that equation of line having negative slope and positive intercept. Right, this is an equation of line in which there is a negative slope and positive intercept is present. So let us begin the drawing of the given graph of line. Okay, so we are going to plot a graph between y axis as well as x axis. We have drawn the y axis as well as we have drawn the x axis. So this is y, this is x axis, right? Here they have mentioned minus m. Whenever the word is minus m, in that case means the slope is negative, right? Slope is becoming negative here. So here, this is a negative slope. And you know already here, suppose the angle, this is theta angle. And theta angle is actually greater than 90 degree. It is actually obtuse angle. Suppose it is a 135 degree, and we know tan 135 degree is negative in. So here, this is a angle. So in this case, m equal to tan theta. Here in this case, it is negative. It is a negative because the angle here, theta is greater than 90 degree. Whenever theta is greater than 90 degree, tan theta is always negative. So here, when the angle is greater than 90 degree, we can say it is a obtuse angle. It is a obtuse angle, and this part from here to here, This is actually C. So C is a positive intercept here. C is actually the intercept here. M you already know it is a slope. M is a slope of line. Y is actually the dependent variable and X is the independent variable. Y is the dependent variable and X is our independent variable. If the value of X is changing, similarly the value of Y will be changes accordingly, because value of Y depend on the value of X. So hence we can say X is an independent variable here. So this is all the graph we have. So 3 graph we have discussed, right? We have completed 3 graph, their slope we have discussed in that way. So switch for the next one. We are going to deal with the next graph, graph number 4 here. So we have the 4th graph, graph number 4 here. So 4th graph is actually y equal to mx minus c, right? Y equal to mx minus c. So this is actually equation of line having positive slope and negative intercept. So here the intercept is actually negative, right? Intercept is actually negative here. So let us begin with the drawing of the line here. We take y-axis as well as the x-axis. So this one is actually a lengthy one. Let me actually draw the 2 lines accurately. So here we have, right? So here actually what I have done, this is a y-axis, this is your 0, this is minus y-axis, right? Sorry, here it actually 0 is there, this is minus y-axis in this case, here this is minus x, this is actually x in that case. So here in this case the graph I am going to draw y equal to mx minus c. So this part, the slope of line which I am going to draw, in this case definitely the slope is inclining, it is a positive one, it is a positive slope, but intercept is negative here. Intercept is negative here. So this is 0 up to here. From here to here, this is actually minus c. This is the negative c because it is below 0. It is at the negative y-axis. That's why the intercept in this case is minus c. And the angle between them, this is actually theta angle. Theta angle in this case tan theta is there. Okay. And tan theta is equal to m. So this is a graph of y equal to mx minus c. So this minus c indicates that negative intercept is there. Negative intercept is present here. M stands for the slope. Here the slope is positive, right? Slope is positive here. Then y is already we know it is a dependent variable. Dependent variable we have. And x stands for the independent variable. X is our independent variable. So this is the 4th one. Simply what we learn here, that in this case the intercept is below 0. If it is below 0 along the y-axis, then it is actually a negative intercept. The slope of line is still increasing. That's why the slope is positive. That's why the slope is positive. That's why it is positive m, or simply we say m only. Switching for the next 5th graph we are going to discuss. So 5th graph is actually the another one. So we have the 5th graph. In that case, we can simply say the formula for that, y is inversely proportional to 1 by x, or we can say y equal to 1 upon x into k, right, into k, or you can write it as y equal to kx. So in this case, when you remove the proportionality symbol, then you are getting the k. K stands for the proportionality constant. Okay, proportionality constant, right? Proportionality constant is present here. Means whenever you remove this symbol, let me show with this one. So whenever you remove this symbol, then the k will come, right? Whenever you remove the proportional symbol, then the k, that is proportionality constant, will come in that case. So let us draw the graph for this one. Now the graph for this part is typically different. The graph of this one is actually different. Previously what we have learned, in these cases the graph is actually linear. Means here it is a linear graph. This is linear. This is also linear slope. As well as in this case also it is a linear slope, and here is also linear. So all of them have linear slope, but in the fifth one it is completely different in that case. So in this case, y equal to kx, y equal to k by x, it is a formula, or we can write it as, in this case, or we can say xy is equal to k, that is a constant. So we are going to draw the graph between y is equal to 1 upon x, or y is inversely proportional to x, or simply xy equal to constant. So simply you draw the two axes, one is y axis, another is x axis here. We have drawn the two axes here. So this is your y, this is your x, right? So k is a constant, let it be whatever value it is. So suppose in that case, if the y value, if you take the x value is equal to 1, y value will be k by 1, that is k. If you put the x value equal to 2, then what is the y value? Y equal to k divided by 2, that is we can say 0.5 k. Similarly, if you put x value equal to 3, y value becomes in that case k by 3. That is coming 0.33 something. So there is actually continuous decrease is happening. So we can draw the graph for y is inversely proportional to 1 upon k. It is in this manner, right? It will keep on decreasing in that way. Suppose this is 1. Here it will keep on decreasing in this manner. With different color I am showing here. Here we have. So in this way the graph is decreasing in this manner, right? So this sort of actually curve which we observe, this sort of curve we say as a rectangular hyperbola. Rectangular hyperbola graph. Rectangular hyperbola graph. So this is actually the nature of the graph. Okay, so when we plot the graph between the y-axis as well as x-axis, when the equation of line is actually y equal to 1 upon x, or y is equal to k by x, or simply y is directly proportional to 1 upon x, or simply y equal to, or simply we can say xy equal to k. In those cases the graph is actually rectangular hyperbola. So this will be useful in case of the Boyle's law. In Boyle's law, this graph is very, very useful. So the nature of this graph is rectangular hyperbola. Going for another one. Going for next one. We are going to deal with the sixth equation of line. We have the sixth one here. So this is actually the sixth equation of line y equal to k x square. Y equal to k x square we are going to discuss. Right? Y equal to kx square. So when we say about the y equal to kx square, let us take some example. Let us take the value of x in that case. Suppose x value is 0, then y value will also be k into 0, it is 0 only. If we put the x value is 1, then y value also k into 1, that comes out to be k only. If you put the x value equal to 2, y equal to, here the squares are there in that case. So k into 2 square, it becomes 4k. Similarly, x value equal to 3, y equal to k bracket 3 square. Square of 3 is 9k. Similarly, x value equal to 4, then y value comes out to be something k into 4 cube, 4 square, that comes out to be 16k. So what you are observing, that the graph is actually increasing. Value of y is actually increasing very rapidly. Value of the y is increasing very rapidly in this type of equation, right? So in this case, so whether it is y equal to kx square or simply y is directly proportional to x square, no need to worry about. If the nature of graph, they are actually asking for it, right? If we have got this equation y equal to kx square, so we can plot with respect to y-axis as well as the x-axis. Here we have one axis, y-axis is here, another we have the x-axis here. So when we have to do the plotting of such type of graph, you take the variables in such way. Here there is y-axis, here we have the x-axis. So when you try to plot this graph, initially the value is 0, 0 here. This is the origin point. At 0, 0, it is the origin, means y-axis as well as the x-axis both are 0. But once the values are increasing, once the value of x are changing, so the nature of graph will become parabolic. So very sharp increase has been observed. Very quick increase has been observed in that case. This sort of graph we say a parabolic graph. So this is your parabolic graph, right? This is actually nature of y equal to kx square equation of line. This is the nature of the graph which is plotted between y-axis and x-axis, right? So this is the idea. Switching for the next one. Next graph we are going to discuss, that is actually exponential graph. So simply what we understand, whenever the value of x is changing, similarly the value of y will be depending on that, right? Similarly value of y will depend on the value of x. So k is actually the constant, that is a proportionality constant, right? That is actually part of slope in only. Next one, going for another seventh equation of line. So we are dealing with the seventh one. Seventh one here in that case is y equal to ex. Okay, y equal to e raised power x we are going to discuss about. Here we have y equal to e raised power x. So this is actually the nature of this, means the nature of graph is exponential. Nature of graph is exponential in this case. So very quick rise will be observed. Very fast rise will be observed in this case. So here we have the y-axis. And next we have the x-axis accordingly. Right? These are the values we have got. So on one side there is y-axis, another side we have the x-axis. And we already know about the y and x. So in that case y is actually the dependent variable and x is actually the independent variable. So here we have y-axis, here we have the x-axis. So in this case, if x value equal to 0, right, x value is equal to 0, then y equal to e raised power 0, that's value comes out to be 1. When x value equal to 1, then y value also changes very fast. So y value is e raised power 1, it comes out to be 2.718. when x value comes out to be 2, right, x value comes out to be 2, in that case e raised power x value, so y equal to e raised power 2, the value of this very very fastly rising 3.898 7.389 value is coming. So see here, very very fast rise has been observed. Similarly, x value is equal to 3, then y value is actually rapidly moving, e raised power 3, it comes out to be 20.085. so see here, the difference is very very large. Okay, difference is very large. Okay, difference between two successive y values is very large. So very sharp rise has been, very quick rise has been observed, very very large difference is there. So the nature of graph for this one, in that case, suppose this is the point 1. So the nature of graph will be in this manner. Let me show. So it will very fastly, it will rising in this manner. So this is the nature of the exponential graph. Okay, this is actually the exponential graph nature. So I have shown the each and every values of the e raised power. In that case, if e raised power value is 0, what will be the value of the x? So whenever, see here, x value is 0, y value is 1. So this point is actually 1 here, 0, 1. X value is 0, y value is 1. When value is actually 2, so when value of x is 1, in that case, it will be something around 2 point something. So here at this point, y comes out to be 2.718. And here, if the values are changing, the rise is very, very rapid. So this is the nature of graph of y equal to e raised power x. Okay. So this is 7th graph, and the last graph which is left, that is the logarithmic graph. Okay, that is a log graph. So we are dealing with the final graph, that is the 8th graph, that is y equal to ln x, and also we are dealing that y equal to log x. This graph also we are dealing. Both the graph are very similar to each other. The relationship between ln x as well as the log x we are going to discuss. So in that case, the relationship between them you can understand easily. We already remember that y is actually the dependent variable and x is the independent variable. Right? Y is actually the dependent variable and x is actually the independent variable. That thing we already know about. But still, some relationship, the idea we are going to discuss about. So the graph of this one, when we going to say about. So here, they're actually the axis. I'm showing this graph. We have taken the two axes. One is y-axis, another one we have the x-axis here. Right? So this one is y, this one, in this case it is minus y-axis. Here we have the origin, that is 0. In this case it is the x-axis, that is the positive x-axis. This is the minus x-axis. All the axes I have shown. So suppose I have to draw the graph of y equal to ln x, or we can say y equal to log e power x. So the nature of graph in that case, it is actually first from the negative coordinate, that is minus y-axis it will go, then it will go for the positive one, and the rise is very very fast in this manner. So very fast rise is observed in this case. So in this way, the graph, nature of graph is this. This is actually called logarithmic graph. The graph plotted between y and x axis for the equation of line, y equal to ln x or y equal to log x is logarithmic. So this is the nature of the graph. This is your nature of graph. So the values are very, very fast rising in that case. Very, very fast rising in that case. So first it is in negative coordinate, then actually it will keep on changing in that way. It will keep on shining in that case. So this is the all idea regarding the nature of graph. Everyone understand this and please share to other friends so that they can also learn the best from you. So everyone like, share as well as a comment if you have understood this concept. Any difficulty, any doubt, please put your doubt in the comments. I'm there to help you out. That's it for today. Thank you for giving your valuable time.